Dear friends, in this video, I will address part 3 of support vector mission in the context of a journey in support vector missions. Part 3, we are focusing on how support vector mission works in practice with a simple example involving a nice data set. Let's look at the problem. There is a file that contains information about 24 companies, out of which 12 of them are classified as least admired, and the remaining 12 classified into most admired. The features that are used for the classification purpose is EBITDA's, earnings before income and taxes divided by total assets, and ROTC, return on total capital. These are the two features that are used for classifying the company into least admired and most admired. So you are asked to apply support vector mission modeling to classify a company as most admired or least admired. Now, draw the hyperplane separating the data points with Wx plus b is equal to 0, Wx plus b is equal to -1, Wx plus b is equal to +1. Of course, this problem is adapted from management science modeling by Winston and Albright purely for classroom discussion. The data set is taken from there. Now, we have done the modeling. I have done the modeling in spreadsheet, Microsoft Excel. I am presenting the solution and the discussion thereof. The data set with modeling and solution display. W1, W2, B, and you can see the coefficients 24.9671, 91.9842, minus 14.4941 is the intercept. And the goal is to minimize the objective function that we have discussed in part 2. And the ratios are all there here, 24 companies. And we have to do one thing in the support vector modeling part. Least admired is classified as -1. You can see all through least admired coded as -1. Most admired is coded as +1. This is a requirement for the formulation of the quadratic programming modeling involved in the support vector mission. We compute the score using the hyperplane equation, and the constraints are satisfied. Then the sign of the score, sign score function is there in Excel. It returns, if the score is negative, it returns -1. If the score is positive, it returns +1. So this is the actual Y. This is the predicted Y. Now you can classify them, how accurate the model is. This is the hyperplane equation. Wx plus b is equal to 0 using Excel graphics. It has been done. And the hyperplane equation once again is displayed above. ROTC on the vertical axis, EBITDAs on the horizontal axis. Then you have the two equations that are called the density boundary point equations. One is above the hyperplane is a +1. Below the hyperplane is a -1. And you can see all the points are separated. All the 12 points are away from the hyperplane, both on the -1 side and the +1 side. And this is the beauty of support vector mission. In this particular simple example, This is a case of linear separable data set, so you don't have a problem. This is a center line, and the data points are pushed as much as possible from the center line, and you can count them 12 below the hyperplane and 12 above the hyperplane, and the distance margin, which are the boundary lines drawn above and below the hyperplane, is maximized. So this is the beauty, and we have modeled it in Excel. Let's see the classification. 100% accuracy. All the 24 observations are correctly placed. Most at my 12, least at my 12, and accuracy is 100% actual versus prediction confusion matrix. Of course, in every case, it will not happen. In this particular case, this has happened, and that is the beauty of support vector mission. The accuracy part, it addresses magnificently. Of course, in complex problems, we will have to use kernel tricks and other advanced concepts. But the idea here is to introduce to the learners how support vector mission works. I'm hopeful that you would have enjoyed the presentation. It will lay the foundation for you to build on more advanced topics in support vector mission. Thank you very much, ladies and gentlemen.